Hello, my name is Esther Reisinger, and today I'm going to be giving you a beginner's guide to axle design and retention. In FRC, there are 4 very common types of axles, among many more different kinds that are specific to certain designs. But today, to keep things simple, we're going to stick with the 2 basics. That is the half-inch hex, thunder hex, or round axle, and the 3/8 or 0.375 hex, thunder hex, or round axle. For example of some of the other kinds that are common, there is the churro or hex light axle, and there is a spline XS, which is very commonly found in motors as the shaft that comes out of them, such as the Kraken X60 or X44. Now, I was just mentioning bearings. There are many different kinds of bearings, but for those main 2 axles, these are very common bearings. There is a 7/8 outer diameter bearing with a 3/8 inner diameter that can come in both round or hex bore. And for the half-inch axle, there is an 1.1/8 outer diameter with a 1/2 inch inner diameter. That can also come in either round or hex bores. Those are very common bearings, and you won't be wasting your time if you memorize those dimensions. Now, for actual bearing construction, there are 2 different kinds that are commonly used. There is the flanged bearing, and there is a non-flanged bearing. And a flange is basically the little bit of material that sticks out around the top, as you can see I am pointing to with my mouse right now, and that part can be used for retention and anchoring the bearing into a plate or a structure of some sort that it's going to be spinning or fixed to. Now I can show you some mounting methods. Here I am in an Onshape document, and I'm going to create an axle sketch. Now for the example, I'm also going to be creating a small plate that we can use to show how to retain bearings in certain ways. Now we have this basic sketch, and if you're in an assembly, you can often just go to a hole that you want to draw your axle in. Because if you're working with an older designer or someone in your team who just wants you to help them by designing an axle, just find the bearing hole and sketch directly on that face. So I'm going to create another sketch here, and I'm going to pull over this circle. Now, many students that I meet, they try to make a hexagon with their own line tool. That's going to be very difficult and require so many constraints. A simple thing, given this is a beginner's class, there is the inscribed polygon button. You can click on that, click on the center of your axle, and you can dimension your axle any size that you want. Now, as I was saying in my previous explanation of bearings, there is the 1.1/8 for a 1/2 inch bearing. So that's why I decided to dimension this axle 1/2 inch. But look, this axle, it can still rotate freely. If we just take any one of these lines, we'll dimension that horizontal, and it will snap to fully defined. Keep in mind, the dimension of the axle is generally the circle that is tangent to all of the lines within the outside of the circle. Or you can measure 2 parallel lines, and that's the correct dimension. Never dimension your axle between the 2 points, because that is further away than the 1/2 inch that you desired. Now, since this is the 7/8 bearing, I'm going to make another inscribed polygon, and we're going to make that into a 3/8 hex bearing. This one snapped to position because I already held it in a vertical position to where the axle could define itself via a constraint. I'm going to want that axle to be 2 inches tall. And I want to have both, so I'm going to extrude them in the same extruder for the moment. Now I can go over to the assembly, where I have previously imported plenty of bearings for demonstration purposes. And I'm going to insert all of my parts. So I want this axle to be able to spin freely within the bearings that I'm going to put in this plate. So since this is a 1/2 inch hex axle, I'm going to look for a 1/2 inch hex bearing. And this one is a flanged bearing. So if I wanted to put the flange of the bearing right up here, and I wanted to mate this axle into the center of the bearing, boom. And then we wanted to put another bearing down here. Notice how I'm putting the flange on the outside of the plates. There we go. Now, since I made one plate a 1/4 inch tall and the other plate is 3/16 tall, you can notice that this one sticks through the bottom. That can be allowed in certain assemblies. You'll have to work with the designer or with the constraints of your system. So how does this bearing stay in the wall? Because right now it can pull right out and come right off this axle. And similar with this bottom axle, with this bottom bearing. If I wanted to keep these bearings in the wall, there's two different options. I could either put a bolt that is right outside here and right outside the other side and use just the head of the bolt to go right over this outer race of the bearing. And that could pull it into the wall and prevent it from coming out. But that doesn't prevent the axle from coming out. A very common way to prevent an axle from coming out is to poke a tap hole in the end of the axle. That could be an 832 tap hole that you then put a bolt with a large washer that goes over this inner race of the bearing and keeps the axle from pulling through that direction. And if you wanted to hold it from this side, you could do the exact same thing. If you're going to be putting that washer and bolt, you don't necessarily need the 2 bolts to hold the outer race of the bearing. Now for putting in a 3/8 axle, let's do this. What if we put the flanges on the inside of the assembly? I'm going to mount a round bearing here. Maybe you can get where I'm going with this. Now say you have the flanges on the inside of the bearing and you didn't have anything spinning for a 1/4 of an inch. So you put a gear on here and it's taller, the distance above it is enough for this bearing to want to come out. How are you going to hold it in? You could do the same method as before where you put the bolts on the outside and you hold the bearing in, but that still doesn't contain the axle. If your plates have been set, the distance between your plates have been set by another plate or another standoff or a tube, then you can accurately hold in your bearings by rounding the end of the axle. You don't want to round the whole axle because then the axle can still slide through. So here I'm going to measure the height of my bearing, and in this it says it is this tall. So I'm going to copy that dimension, come back over to my Parts Studio, go to the sketch where I made my axles, and an easy way of, instead of adding another sketch to round it on top, you just turn the circle in the middle from a construction line to a solid line. It may want to blow up the axle. The only reason is because it forgot that the center was connected to it. So now I'll go back to that sketch. I will click extrude and I will go around the outside. And I'm going to remove the distance of the height of the bearing off of there. Similarly, I can do that exact same thing on the other side. I can offset. I can click Entity. Which is this face. And I'm going to remove the same distance. And there we have a rounded axle. Let's go back to the assembly. Now we can see that the bearings held, the axle fits in the bearing, but cannot slide through because of the hex that's left around it. Keep in mind, the circle on the inside of the bearing is the exact same size as the rest of the axle. Many students I've met try to make it a smaller circle because they don't think that they don't realize that there is more material out here that keeps the axle from coming through the round bearing. And that is one great way to mount another axle. Those are two very common ways to do it, and hopefully this video gave you a little bit of knowledge so that when a student asks you to help them with a design or add some axles, you can understand, have options, and work really well with the person.